So, first public service announcement is you'll notice that the title is a little bit dynamic, okay, heading into today. And that's because we wanted to sort of differentiate a little bit from what everybody else is talking about. We kind of got feedback, context engineering, everybody's talking about it. We kind of got feedback, vibe coding, everybody's, And so we have kind of an ambitious afternoon planned for you guys. I was speaking with some folks that just heard about this the other day from 5 minutes down the road just a minute ago, and I think, they're new beginners wondering, do I really need a laptop? No, you don't really need a laptop. But we are going to show code today. So if you don't like code, you're not going to like every part of this. So this is going to be geared towards builders or people that want to manage builders. Now, if you do need some help getting started with some of the coding tools that you'll see Wiz using today, like Cursor, we do have folks as part of the AI Makerspace community that are here that can help you kind of get on the path today. But this is going to be a 3-hour workshop, okay? So just to be clear with everybody, you don't have to stay the whole time, but we're going to make our way through prompting and the responses API from OpenAI, RAG and MCP connectors also with the responses API, agentic search and multi-agent systems with the agents SDK. And of course, we're going to bring some Vivity vibes for you guys. By the end here, we're going to show some live vibe coding. Also, how do you build this with Lovable, v0.dev, but how do you actually build it yourself too? So if you're sticking around for vibe coding, you're going to be sticking around for a while. Just heads up. Okay? All right. All right. I think we're probably ready to rock then, because I already am 2 minutes over. So live stream, go. Welcome, everybody, to How to Build ChatGPT. Today, we're going to walk you through prompting, RAG, agents, vibe coding deployment, and we're going to put this into context. Okay, we're going to talk about some of the more advanced context engineering things we're hearing from the field and that you really need to know if you're going to build these systems today. Not necessarily specifically for coding agents where a lot of the state-of-the-art stuff is going on, but for like stuff that we want to build for enterprise. All right. We've got a lot of stuff to get through, but I'd first like to properly introduce you guys to me. I'm Dr. Greg, and to my co-founder and CTO of AI Makerspace, Chris, the LLM wizard, aka the Wiz Alexiuk. We are going to be your hosts and guides for today. Welcome to an AI Makerspace live in-person event. We don't do a ton of these. We're primarily online, doing live YouTube events, running live online boot camps for individuals and for enterprises. You see, for 10 years as a university professor, I saw that the only people who were succeeding in a 21st century workforce were those that were using new skills to build cool stuff and to share the cool stuff they built with others. It wasn't degrees, it wasn't PhDs, it wasn't pedigree that was getting people where they wanted to go. AI doesn't care about any of that, as you guys know. It was making stuff as part of a community. That community could be something you do outside of work. That community could be something you're responsible for building within your work. Either way, if you don't do this, you're not going to be able to generate huge ROI for yourself, your family, your community, and the world, or your company. We are on a mission at AI Makerspace to create the world's leading community for people like all of you who want to build, ship, and share production LLM applications, because building in silence isn't enough. Leadership won't notice. It's too advanced. They can't keep up. We're all about being practical, guys. We're going to eliminate all the fluff today. Practical AI education, the kind that creates ROI for people and companies, building, shipping, and sharing, is the secret sauce. We try to make it easy for all of you so you can make it easy for everybody else in your network. Because we all need to embrace the LLM edge and focus on what we don't yet know, which is always more important than what we already know. So the first thing we're going to talk about today is something very simple. We're going to talk about prompting. Prompting is dead. That's what I heard. And we're going to talk about the Responses API from OpenAI and a little bit of the history and background that got us to the Responses API. By the end of this part of the session, we're going to have 4 parts of the session. Here's what you're going to learn. So if you stick around for the next, let's say, 45 minutes or so, you're going to understand this kind of how to build ChatGPT series that we're going to walk you through over the next 3 hours. You're going to understand how the Responses API actually works and how its evolution from the Chat Completions API is the key thing to pick up on. You're going to learn how to context engineer your application as you think about just building something very simple. And so we'll build, ship, and share our first app in the first part of this session. So we set out on this journey to sort of build ChatGPT. And you got to get started where everybody gets started. You got to kind of look at the thing. So let's look at the thing together. When you open ChatGPT, you see something like this. You got kind of a weird lighting thing up top. I don't know if maybe that's ideal, but I think you guys understand and have used this enough that you can sort of go and you can ask. It's very simple user interface, very vibable. And you can go to more and you can look at this and you can zoom in a little bit maybe and you can see like, okay, we can add photos and files. Okay, we can also add other stuff like MCP server type connectors. We can also do not just RAG, but we can do agents. Now, when we use the search bar, we're going to leverage agentic search fundamentally. It's going to have access to the internet. It's going to be able to basically do Google search in the ChatGPT bar. But you also see like agent mode here. We're not going to cover that today. Okay, that's a bit more down the rabbit hole. It requires multimodal models, computer use, and a bunch of other stuff. Deep research, we're also not going to cover, but we will be covering voice and deep research in an upcoming event on our YouTube channel. We're also not going to cover images and pics. We're not going to cover Canvas. That would be a pain in the you-know-what to build that front end. And the study and learn thing, I mean, it's kind of cute, but it's not worth our time as engineers here. So we're going to kind of really focus on the core of what makes this up. We're also not going to do the reasoning models and the auto and the thinking stuff. We're going to focus on kind of the core here. This is important, and you should ask, how do they actually do this? How do they set this up? But realistically, like when you think about reasoning, when you think about doing more LLMs, when you think about auto-choosing the LLM stuff, when you think about adding voice mode, when you think about adding all of this stuff that like doesn't necessarily, you know, and these are always popping out, the new things. It's not necessarily going to be the same type of thing you need in your application for your users, but you will probably need prompting, RAG, agents, like for sure. Will you need all the other stuff? Well, that's up to your users more than it is up to you, frankly. ChatGPT is cool, but they have a lot of users. So Wiz, first little discussion-reno here, all right? Are most apps today built using these features?
I mean, a lot of them, yeah.
Yeah. Is this like enough?
I mean, probably, yes, right? Especially for more simple consumer-facing applications.
Yeah.
Most certainly that is enough.
Right.
Probably way overkill.
RAG
right?
in prod, I think there's some talks on that.
Yes.
Agents in prod. You're saying they're not using study mode. They're not using Canvas. Okay. If we focus on the essentials here, and oftentimes they're probably not even using deep research, but maybe we're starting to get into this space of like doing a little bit deeper company-specific research. That could be a cool thing.
Yeah, I think it's like, you know, we're seeing applications that are following some of these patterns as their primary pattern, as opposed to many that are combining, say, like 4 out of the 7 or whatever.
That's right.
As well as something like memory is going to be way more often leveraged than something like study mode or canvas.
That's right.
Definitely.
Yeah, like deep agents, right? We gotta stay in buzzword
ambient
compliance
agents.
here.
Yeah.
That's right. Long-running agents, right? Okay, so we're gonna get agentic today, but thanks, Wiz. We're gonna keep it simple for right now. Okay, and let's start where you got to start if you're going to learn this stuff. You got to start with hitting a simple LLM via API. Now, this started in March 2023, updated in 2025, and it's an important kind of update to think about in terms of we see the kind of maturity of the MLOps industry as well happening in these last couple of years. It used to be this idea of system user assistant prompt, and now we're seeing this update where we're actually really focused now on the developer and what the developer can change. We're sort of seeing, yeah, it's the same kind of idea as using the system prompt, but we're being more explicit about this is actually for the developer. It's for you to dial in for your users. I was talking to one of our community members the other day, and it's really important when you're in a big enterprise to make sure that your questions that you're expecting, like one of the things that people are concerned with now is like, how do you automatically identify the persona of the person asking the question? Because if I'm a data analyst, I want a strategy for now communicating this to leadership. If I am leadership, I want the AI to give me the goods directly. And so it really matters what your user experience is like, and this is your problem as the developer, as the engineer. It's not the sort of system-level prompts problem that kind of is at the root of the GPT models themselves. So we're going to pass a list of role content to the LLM. Basically, the LLM is going to return the next message. It's going to return this kind of assistant message. And it's a very simple idea. We do a request, we get a response, and this chat-style model syntax is kind of this chat completions API thing. It's the standard that everybody has used since then. Instead of just input-output of the LLM, we're doing list of messages in, single message back out, and we're growing the list. We're growing the context. We're growing the conversation thread, if you will, in an agentic kind of context. And so you can look at the roles, and you kind of have this kind of conversation happening in the API when you start to build these applications. And so the developer, those are the instructions. That's what you're going to kind of work on. The user, that's, of course, you testing it, or it's your actual user. And the assistant is either you acting like your user, or acting like the AI, or it's you actually getting a feedback from the AI. Now, this user assistant pattern, you can leverage it to do, let's say, few-shot prompting. Give it a couple examples, but as we've seen in context engineering recently, you want to be really, really careful about the few-shot prompting that you're doing. You don't want it to just be sitting in context all the time. That's kind of bad context management strategy these days versus like, yay, hype prompt engineering of years past. So the developer is going to be all about providing those instructions. We're going to prioritize those ahead of user messages. The user, that's pretty self-explanatory. And you can provide examples, or you can just get stuff from the assistant. Now, in June 2023, OpenAI came out with something called the function calling API. This was kind of important because we actually use it all the time with agents. And what's actually at the root here is you have a fine-tuned model that can both detect when a function needs to be called and respond with a JSON message that adheres to this kind of function calling signature. So this function calling was also extended to just sort of general JSON mode in November of 2023. It turns out when you just tell it, hey, always output in JSON, it doesn't do a great job always outputting in JSON. So they had to fine tune it to get really, really good at this. And JSON is kind of useful for the things that we need outside of function calling. So we're starting to get more into kind of the weeds of connecting our AI applications with more classic applications. And again, we're in this request response space. When we talk about tool calling, when we talk about agents using tools, we're talking about function calling. That's the TLDR. These structured outputs that we want are going to allow us to then execute the function code. We'll come back to that later today. Now, in November 2023, and also released then in 2024 in April, the OpenAI Assistants API came out. And this was their sort of first cut at agents. We called them assistants back then, if you guys remember. And these assistants, this was like the next thing, right? And it's just going to use OpenAI's models. It's going to be able to access files, aka do RAG. It's going to be able to maintain this persistent thread. It's going to be able to do something a little more agentic and call tools. We're going to have a little bit of this memory and persistence. So this sounded really good. And this was kind of obviously the next evolution. The thread was just a conversation between the assistant and a user, system user assistant, right? So the assistant's flow would be you create a thread, you add the messages, you run the assistants on the thread. It was very, very kind of straightforward. We could really implement these patterns of prompting and RAG and agents even back then. Now, at the time, you see they used code interpreter, retrieval and file search, and function calling. Kind of AKA, in the middle there, RAG and AKA function calling is kind of agents. Code interpreter, we've seen that kind of thing, agents' ability to write code has really blown up since that time. And, we saw things like this, where, the thread is, the personal finance bot is the assistant. The thread is going to have the user message go in. It's going to run basically the tools, It's going to run the steps. It's going to run the workflow, we might say now. And so you can kind of imagine this kind of vibe of input-output, and then what happens behind the scene, we kind of don't really care. This has obviously been what we've expanded to today. We want to put get weather, and then we want to get the weather. As the developer, we have to worry about what happens in between. But as the user, we don't care, right? And so, it's just an agent. So that kind of was being used for almost a year before Responses API came out in March 2025. And this came out with new tools for building agents. This was kind of released at the same time as the OpenAI Agents SDK. And they said, this is our new API primitive. It's better than ever for building agents. They said, this is going to give you all the beautiful simplicity of the chat completions API, and it's going to give you those sweet, sweet tool use capabilities of the Assistants API. And as you guys may or may not know, the LLMs that we've been training recently, they're much better. You see them in all the releases at agentic tool use. So the LLMs themselves are being trained to be better at this, and the frameworks are adapting to that reality. With a single Responses API call, developers will be able to solve increasingly complex tasks, blah, 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 using multiple tools and model turns. So as model capabilities continue to evolve, we believe the Responses API is the answer, providing a more flexible foundation for developers building agentic applications. So we got even more tools like web search and computer use. And that's cool, because web search is something we definitely need like out of the box just to be able to do a simple search. So this is sounding like maybe we're on to something here. So quick discussion here was system user assistant. Okay, fine, developer user assistant. This is the gold standard today, right? But there's new stuff on the horizon people should probably think about that's beyond the scope of today.
Yeah, I mean, so I think we're all used to system user assistant at this point, right? If you're building chat applications, it's this idea that we have different message roles, right? And they interact with the behavior of the LLM in different ways. And kind of the gold standard was and continues to be, until there's a major shift, system message, which is kind of like instructions that we don't want to necessarily hear directly in the messages. User, hopefully self-explanatory. That's what we, the user, say. And then, of course, assistant, right? Whatever the LLM spits out. Now, with OpenAI moving toward the Harmony format.
Harmony, what's that?
There's even more stuff to care about.
God. There's more roles, even more roles.
There's more roles, and there's breakdowns within those roles. There's things like channels. And this is all something that directly interacts with the chat template. And the reason that matters, right? Because obviously, it's like, okay, so what? the LLM is trained with these sequences of tokens in mind, and it's trained with that chat template, which means that we're kind of like moving our application, the way we design applications and think about applications, we're moving it into the training step, right? So instead of having a model that we have to coerce to do what we want, the model is actually trained from the hop to be aware of an environment that has an application associated with it, that has sessions, that has different parts of the UI that we might care about. And that makes that response that we get much more tailored to the use cases that we have. And this is the kind of idea. It's one of those like low-level silly things, but it's super impactful when it comes to the actual usage of the system. So it's still something you got to care deeply about.
So everybody knows this. But importantly, the way models have been trained to date also leverages this. And as we train models to do ever more complex things, even from this level, like with the Harmony format, like with GPT OSS that came out, we should be keeping a lookout, as the models that we train become more like agentically good natively at stuff. That's sort of a key thing to pay attention to. Maybe this is starting to expand a little bit.
One of the really nice things about this is that that's all dope and great, and you might think, oh man, my life just got harder, right? APIs solve this for us, right? So when we interact with the API, we don't have to like physically program the correct sequences of tokens, right? This is being handled by the API you're hitting or the prompt template that you're using. So though it's very important, and though it is an interesting place of research and work, we interact with it the same way we always do, which is through that API, which is going to handle the translation for us to whatever format we're using.
Yeah, okay, all right. So let's keep it rolling here, Wiz. Thanks. All right. And so, even simple prompting, right? Is it really as simple as it used to be? Well, watch out. I mean, it's not prompting anymore. It's context engineering. And as the new models come out, it's important to put this in context as well, because as they become more capable, we need to make sure that we're building applications that take this into account, because we're far from February 2019 anymore, where we don't need explicit supervision. We can do stuff without fine-tuning. We can simply prompt the LLM, and that's big dope. The prompting idea is like we're just giving the LLM instructions. We might say in the context window, we might say we're doing in-context learning. Of course, this was the GPT-3 paper that introduced us to this idea where we're just putting stuff in the context window. When we put the right stuff for big enough models, we go from just no shots, just instruction only, to 1 shot, to 2 shot, 3 shot, 4 shot, 5 shot, 32 shot. We get much, much better very, very easily. And GPT-3 is like, okay, we can scale up. That's dope. And we started to learn some of these ideas of prompt engineering. And be very clear, be very specific. This is the #1 rule. It still is. Make sure that your instructions are exactly followable to the letter. Now, we used to talk about context in terms of roles and personas. You're a teacher grading a quiz. You're a helpful assistant, this kind of thing. Now we talk about this in a broader context, of course. We talk about it in retrieved context. We talk about it with RAG. We can also modify the input. Now, whether or not we should add 1 shot, 2 shot, few shot to the context window, that's something for the context engineering people working on coding agents at the edge to maybe chime in on here. Again, also coding is a very specific use case, not like enterprise docs. So whether or not we should be doing a lot of this to prune and to add context at the right times in our conversations is something that the research isn't out on yet. Maybe next year at MLOps World we'll know more. But this few-shot learning, this is also from the GPT-3 paper. I mean, these are all classic ideas from 2020. And of course, we see things like the chain of thought. This is, of course, something that's gotten a lot of attention, a lot of hype. We used to tell the LLM things like this, think through step by step, but now they already do it. This is kind of an old paper now from Google in Jan 2022, where we can do reasoning steps. Now we have reasoning models. And I personally kind of default to reasoning models most of the time because a lot of stuff I'm doing isn't really, really tied to getting done right now. Finally, the output, the format, is really important, especially if you need to, I don't know, do a tool call or do a function call like we just talked about. Context, of course, has kind of subsumed this entire space, which is interesting. So we see prompt engineering, we see RAG, we see kind of structured outputs out there on the edge, but there's a lot of different ways people are visualizing this and thinking about this. So it now includes things like, what's the state? How do I keep memory in the sessions? How do I keep memory across sessions? How do I do this in a more long-running way? And so we might say context engineering has kind of subsumed all of prompting and RAG. Of course, when you see the LLM operating system of the future, you see all of these basic patterns like prompt engineering and RAG and agents. And we'll build all of these today. You know, again, Responses API is your guide. Like, Responses API is okay, it's dope. But we cover a ton of different frameworks on our YouTube channel, and we don't actually leverage Responses API, you know, in the course we teach. But this is something that we do recommend is a great place to start learning about this stuff. And it might work for you, it might work for your org. So prompt engineering is no longer just this. Like, where's the reasoning, you know, exactly? Where's the agents, exactly? Where's the good stuff in ChatGPT, exactly? And where are we incorporating this idea of these models being natively better? You know, GPT-5 comes with its own prompting guide. It comes with its own tips and tricks to make the model better. We're seeing things like workflow predictability get talked about now. We need reasoning itself to be persisted between tool calls sometimes, especially for more complex systems that have one or more agents, or effectively two agents when one agent is called a couple times in a row. We're seeing words like agentic eagerness now. And this is just literally to prompt a new model, okay? Agentic scaffolds can span a wide spectrum of control. Delegate or elevate type stuff. You know, how tight of a leash do we want to keep the model on? And these are all important questions for us to ask and for us to think about. So, you know, Wiz, from a developer standpoint, how does prompting change in an agentic paradigm? I mean, getting your tool calls and your tool descriptions really dialed in, thinking about how, you know, the agent is going to make decisions like a human would, and pre-prompting that ahead of time. What are some other things people should be thinking about?
Yeah, I mean, it's the same stuff. We like to think, because the systems got more complex, that the kind of fundamental patterns of anything to do with the LLM's prompt or input context window has changed. It really hasn't. It's the same rules that we had, you know, when we got started with this a long time ago. You need to be very clear. You need to be very well aligned to what the goal is. You can't have ambiguous prompts, et cetera, et cetera. The only thing that matters is now that this prompting stack is at like every single layer of what we're working on, right? So instead of just doing this when we're typing in a ChatGPT, we have to also consider this when we're designing code, or when we're writing doc strings, or when we're anything really to do with the kind of code related to agents is just a series of prompts. Even what your functions are called or tools are called, right? The patterns you use to call them, the type hints you give, all of this stuff is prompting now, right? And I think that's the big lesson for, you know, what has changed, is that we're no longer just writing like a prompt that we then send it to the LLM. The whole application we design is a prompt that winds up being exposed to the LLM. This is something new, but it's easy to get used to, right? Instead of writing code for your fellow humans, you're writing it for the model. It tends to overlap quite significantly with good readable code, which is nice. But the idea is that you know, we're really prompting at every single layer of the stack. And I think if there's one piece of wisdom that I can impart to people getting started, it's to think about it that way, right? Every time you write a line of code, you should assume that at some point LLM is going to consume this code, if not directly through your application because it's a tool, for instance, then it's going to be consumed by whatever AI assisted development you're using. So you should always write as if an LLM is going to read it. And LLMs famously, though they have PhD level knowledge, are dumb as hell. So,
And so even comments, like you're writing comments in your code, that's still part of the prompt. Okay, so
100%.
I think you're going to walk us through how to think about now building with the Responses API. And if you guys want to follow along with this notebook, go ahead and QR code this up, but you don't have to. And you can follow along live. A challenge for all of you trying to get after it today, advanced developers, can you actually follow along each and every notebook? If you can, we have no swag for you, but we have a sticker. Okay, we have a sticker. We'd love to give you one. So Wiz, first demo of the day, Responses API with context engineering in mind. The Wiz. Let's go.
All right, hello, I'm Chris. I'll be your code guide today. We're going to look at some code. That's always fun. I'm going to make sure to zoom in my screen quite a lot once it comes up here, which it will do at some point, I'm sure. Probably. Oh, look at that. We got code, and we're going to go. Boop, 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 boop. Those of you in the back, are you able to see the code? Okay. Excellent. So we have a little README here. Not worrying about that. So we're going to talk about the OpenAI Responses API. So there's a lot of conceptual information that goes into building these systems, right? A lot of what we're talking about are patterns that we can leverage through code in order to build something interesting. And so what we're going to talk about is the actual API itself and different things that we can do with this API. It is quite powerful in terms of, all of the neato things that we can add to it, which we're going to explore through the rest of the workshop. But the takeaway here is that this is a good API. So it offers many advantages: simplified interface, built-in reason. All that stuff's great, and you can read it in the notebook. We're going to go look at some code. This will require you to have an OpenAI API key, of course. This is using the Responses API for OpenAI's models, so you'll need to slap that in here. And then we're going to go ahead and set up our client. Easy enough. And then we're going to look at what a basic response looks like. Now, this is very familiar, hopefully, to everybody, because it looks very similar to the chat completions endpoint, which is probably what you've seen up to this point. Chat completions completes chats. There you go. The actual Responses API is not too dissimilar to this. We're going to define what model we want to talk to, and then we're going to give some kind of input, and then we're going to be able to extract the output text. Hopefully, this part's not too crazy. The next section we have is our slightly more involved example, right? So this is, we have the model defined. And we're also going to define a reasoning effort. So the GPT-5 series of models has kind of 3 reasoning modes that we care about, which is low, medium, and high. The idea is that selecting low will get you a response faster, but it is less likely to be the best response. Selecting high will give you a response much slower, but it is more likely to be the correct response. For most tasks, we don't care about reasoning, especially when we're talking about agents. We care deeply about reasoning for things like planning, for things like making complex decisions, or for doing PhD level math, which oftentimes we're not building our applications to need to do. Otherwise, we can get away with kind of low reasoning in all situations. One of the things that we're not going to talk about extensively here, but is important when you're building agents, is the idea that quite a lot of the stack you build can be done by a very simple, very small, very fast, and very efficient model. This is things like doing tool calling in a loop, right? Don't blow your budget on that part. Then we see our instructions. Now, very, very importantly in the Responses API now is that this instructions is a easier to understand way to think about the system message. So this is what you would traditionally think about as the system message. OpenAI has made some changes so that system message means something else, and they're calling this the developer message now, in case you've heard that terminology. But the basic idea is straightforward. This is where we put how we wish for the LLM to behave, set ground rules, yada, yada. And then the input is the same. There you go. And you can see, because we asked it to talk like a wizard, we get this absolutely insane output. Seeker of speed, heed these arcane laws of NumPy. Very cool. It does know to talk about vectorization, which is nice. But there you go. Instructions are important because instructions let us guide or steer the behavior of the system without making our users do it. Finally, of course, we can look at what this looks like if we were to, instead of using the predefined parameters in the API, we could pass in a list of objects. In this case, you'll notice that that instruction goes to the developer message, and then our content, so this is our question, goes to the user object. Now, the reason this is, again, is because in OpenAI words, the instructions are a developer message. It makes sense when you think about it, right? A system message should come from our system, and the developer message or instructions should come from us, the developer, and then the actual interaction should come from our users. So there you go. Anyway, same thing though. Vectorize, talks like a wizard. You love it. What more can you need? Next, you're going to see this a lot. Pydantic, a lot. It's everywhere. If you don't love Pydantic now, you should very quickly start loving Pydantic. It is the way in which we encourage all of our systems to know what the heck the output is supposed to be. So let's look at what this looks like. We're going to build this base model. This base model is called calendar event. It has a name, a date, and participants, and these have different types. If we wanted to define this to the LLM directly, we could, but it would be tedious and kind of take a long time and be a very gross-looking, verbose JSON blob, which we certainly don't want to deal with. This Pydantic integration allows us to not have to worry about that, instead defining this. You might ask, well, why is this important, right? Who cares? Just like type hinting for functions in Python or other languages that have actual typing, it's important to know what the output is so that you can be confident about doing operations with that output, right? And this is a way for us to enforce this behavior from the LLM side. And I don't mean suggest, I mean enforce. One of the beautiful parts about the Pydantic integration is that if it's wrong, it will tell you it's wrong. There will be an error, right? So it will validate that the output is correct. So if you wanted to have a float instead of a string, or if you wanted to have a date time object instead of a string for date, for instance, it would be able to enforce that. So it would validate the output for you, meaning you can confidently move forward. The way we actually use it is easy. We just put this, a text format. There you go. Okay, so that part's not hard. Next, of course, the responses API, we know for ChatGPT, you can upload images and stuff. That's dope. You can do that here as well, of course. You can describe the visual appearance of the people in this image, and then you can point to some link, which is as easy as it gets. And then you get this, this description. The images of me and Greg. There you go. That's what we look like. Good job, LLM. Of course, streaming. You know you love to stream. One thing that's important, though, is that we want to be able to stream all the time. We don't necessarily just want to stream if our output is raw text, right? And one of the ways we can do this is actually streaming with that structured generation. So instead of streaming token by token, we're going to be streaming like field by field or token in field. And one of the things that this can help us do is, say we have an object and we have multiple functions that are dependent on the object, but some are only dependent on parts of the object. As soon as those are ready, we can begin the process of doing the next stage of work. So this is going to help us reduce latency. But the big thing is that it's just pretty dope to be able to get that streamed in instead of needing to wait for the longest field to be done, right? So it's going to help us quite a bit. We got a hand there. Of course. Oh, we got a mic. Let's go. Yeah. Oh, we're fancy up in here.
All right, is this okay? With the pedantic models, if the LLM responds and it gives you some sort of malformed thing such that it throws on object construction, is there a pattern built into this where it will try again with the LLM, or what's the typical patterns that you do there?
Yeah, we'll just
Because you need to let it know and say, hey,
off,
you got it wrong, try again.
Yeah, we would handle that. We would just know that it failed after the generation, and then we would, oh no, and we would build our system to retry as many times as we want. Yeah. Great question though.
We are going to do a little Q&A after each part.
Yes.
So you guys can hold your questions for that, and we got the mic runner ready.
Hell yeah. Okay, but the idea is that instead of getting all attributes, quick, lazy, piercing, colors, brown, blue, animals, fox, dog, in one step, we get them, as they come in. And again, this is going to save latency in applications where we have code that depends on part of our object, but not all of our object. We don't have to wait for all of our object to be done. It can also help with an application feeling more responsive, which is typically where streaming shines. And that's about it. Basically, this is what you can do. We've got a little extra bit that you can look at, but that's the Responses API. It's very simple, very straightforward. It integrates with everything we need to make agents go burr. And there you go. Back to Dr. Greg.
So, is this working? Okay.
Is this thing on? Am I right? Oh my God.
It's hard. It's hard to tell when you're the one that's talking. From the code demo at the top, where we had our like JSON prompt, where there was 2 dictionaries, a user, developer, role developer, role user. Is the keyword or the value developer and user, is that standardized? Are those standardized terms that are like recognizable, or are those just like we're using it for the sake of this, or is that like across all industry of everyone using the Responses API, these are standardized keywords that the API or the LLM knows to recognize?
Yeah, so this is an excellent question. There's 2 parts to this to the answer. Number one is on the standardization. Mostly standardized. OpenAI recently has introduced the language of developer message versus system message, which means that there is some, unfortunate, it's a new standard. But the important piece is that it actually isn't going directly to the LLM. So this is something that's interpreted by the API, and then it's translated into the correct token sequences for the LLM. What this means is that if you use, say, a Hugging Face, right, Transformers library, and you pass in like system message to, say, for instance, the Harmony template for OpenAI's GPT OSS model, it will automatically translate when you say system to developer for you. And so, this is the API layer that's handling this translation into those token sequences. However, user, assistant, those are stock standard across the board. You're going to use those every time. The only kind of rough edge right now, as people adopt the Harmony format, which is likely what will happen, is that for OpenAI models, the old system prompt is called developer. But those are necessary keywords. You can't just throw in like a cool guy as the key and then submit it to the API. It will get mad at you. Yeah.
Yeah, that'd be hard to figure out.
Yeah.
I have one more question too.
Yeah, sure.
So with the pedantic, let's say I just create a prompt that says, tell me what's in this picture, right? And the data class that you created that you pass in through there, let's just say it has keywords like chandelier, building, car. And it's a picture of like a portrait of a person. Like how does it figures out like if it can find like a chandelier, it'll then return that as like the data type that you tell it to be? Or like how does that mapping work?
Yeah, so what I would say is that like the way I would encourage people to think about it is like, is chandelier or has chandelier as the field in your data class as a Boolean, and then the VLM or the model will be able to determine if there's a chandelier in the photo and then give you true. Or you could put in like a data type that is conducive to like a bounding box, right? That you could then draw on the image. But the idea is that we can define those pydantic base models, like the extensions to them, and the LLM is going to figure out how to fill the box in. So it's not something that we're going to specifically need to add prompt for, and it can be whatever you want. Now, if you say put in chandelier, right, as the field, and then you give an image without a chandelier, the LLM may stumble on what you mean, right? Especially if you have like string as the type. Maybe it'll say there is no chandelier. What are you talking about? But the idea is that you can be very flexible with those data models. The LLM is going to figure out how to fill those boxes. But once again, and very importantly, the data model is ingested by the LLM, right? Which means the data model is a prompt. And so the way that you design it must be clear and unambiguous if you want clear and unambiguous results.
All right.
Okay.
That makes sense. Thank you.
Yeah. And thanks for getting the questions started, my man. Okay, other questions, concepts, code? Okay, other questions? Yep. And then a quick shout out, if you're interested in learning more about the community, we've got some great community members up front. Sahar and Sepida, they're actually twinsies, and so they're hard to miss, but they're kind of a little bit lower to the floor. And then if you're looking to get started with engineering and you don't really know how to deal with the introductory tools yet, Kat is the one you got to talk to. We call her Kat GPT at AI Makerspace, and her and I are launching a course specifically for beginners. So say hi to Kat at the conference this week. What's up, my man?
Could you once again describe the boundaries of the reasoning, like the low effort and the higher effort?
Yeah, so they use the words low, medium, and high, which are
Low effort.
like they don't mean. It's not like a direct token mapping, right? But so if you are, I'm going to do something a little bit cringe.
Yeah.
Raise your hand if you know about reasoning models generally.
Ouch.
Okay, this is great. So reasoning models do this thing
That
where
was cringe, yeah.
they generate a lot of intermediate tokens in order to get to the final response, right? So the idea is that there's this chain of thought, and it takes like n number of tokens. Now the idea is the bigger n is, right? So the more time the model spends thinking, the better quality response you'll get. What low, medium, and high corresponds to is a low number of those intermediate tokens, a medium number of those intermediate tokens, and a very high number of those medium tokens, or of those intermediate tokens. Now, we don't have exact numbers, but you can think of it as like, 1,000 maximum thinking tokens versus 10,000 maximum thinking tokens versus 100,000 maximum intermediate tokens. And so that's the way to think about it. The LLM is going to spend the least time thinking on the low setting and the most time thinking on the highest setting. And we want to be very careful of when you use that because those tokens are not inexpensive, right? And so you don't want to just say, well, I want my app to be the best, click the high button all the time, because your organization will quickly run out of cash. So.
Yeah. You got my guy started over here. And as chronic overthinkers ourselves, if you guys know what it's like, sometimes you think yourself right into a pit, so you got to beware LLMs can do the same thing. Follow on.
I know like the high is like really expensive. So like in which type of situations would you want to use it?
So let's say, for instance, that this is my general rule of thumb that I follow. If I'm planning out a series of tasks, that's about the only time I want to use high. Or if the actual content is, difficult in nature. So if you're doing something in the biomedical sphere, maybe you're going to leverage high for the final synthesized response. Otherwise, I'm only going to leverage high reasoning mode when I'm planning out the initial set of steps that I want my agent to take. Planning phase is where most systems are going to fail. And so spending the extra time to have a good plan is almost always going to pay for itself in the long run. Otherwise, I would just keep that on low. In fact, likely, I would just encourage you to use a more efficient, a better costed model, which is something like the 4.1 mini or nano model.
Because even off the shelf, these models are pretty good at reasoning
They're
now.
super good, yeah.
Like, why do you really need the reasoning? Okay, all right. Thanks, Wiz. Let's go ahead and call that on Q&A. We're going to keep it moving here, guys, into part 2 of